For years, cloud was sold as a cheaper, simpler answer to the complexity of running your own data centers. But in the era of AI and globally distributed workloads, that story is changing. Egress cost, latency, and GPU capacity are no longer developer topics, they have become board level topics. And to unpack what's really happening and what the future of cloud economics might look like, we have with us once again John Bradshaw, Field CTO for Cloud in EMEA at Akamai. John, it's great to have you on the show.
Great to be back. Thank you.
John, let's start with the basics. Cloud has long been seen as a cost saving move. But in this world of AI and distributed workloads, is that idea still true or it has reached its limits?
Well, it absolutely can be, but you've got to build the right guardrails and take the right approaches that enable that to happen automatically, almost. We see customers, when they're successful in this, have really bought into things like cloud native. They've designed their applications to move wherever their customers or their end users are. And what they haven't done is take the old paradigm of placing a giant bet on one technology vendor or service and then baking everything around that. And that becomes quite critical for the way they work. When they're successful, they're able to take advantage of multiple services from multiple providers that give them the flexibility and no longer lock them in to any one place or any one service. But it's hard. It's not easy, and it's not always been straightforward. One of the challenges with cloud is it's incredible. I mean, the idea that you have this on tap access to compute, storage, networking, AI is remarkable. And I think sometimes we forget how truly revolutionary it is. But it's the same challenge that I have at home. I buy my son loads of Lego. So I have Lego on every surface, in every room, in every part of my house. There's some in the garden, there's some in the shower, because he's 9, but also because there's no incentive for him to tidy it up and keep it clean and make sure he's not just scattering everything everywhere. And because you've got such ubiquitous access to technology, not baking in that go tidy up your room, go put away the Lego before tea time, if those behaviors aren't built in, then that is equally a challenge in making sure that you're doing it in an efficient way. And it does actually work out to be cheaper than historical ways of approaching technology.
You mentioned that cloud can still deliver savings if organizations build the right guardrails. But AI changes the equation. From training and inference to GPU placement and data movement, can you talk about how is AI reshaping the economics of cloud?
That's a really interesting one, because there isn't really a paradigm that lets you reflect it on-prem. So AI came about essentially fairly recently, 5-6 years ago. And at which point lots of customers had already really fully invested in going down the cloud route. What has happened over those years is lots of organizations have said, we must do something with AI. We want to change the way we work. We want to revolutionize our products or whatever it happens to be. And they've started to experiment with it. And teams have been given permission to go and build and develop and let their imaginations kind of drive how they improve their businesses. But we're now in a situation where that technology is changing remarkably rapidly. But at a business level, people are going, well, I've spent all this money and I'm not sure I've seen the return I expected on it, based on the promises or the way that we were discussing it. I actually need to get more serious and more controlled about the way that I want to use it. I also don't want to make the same decisions I made previously, where I bet the house on one provider, maybe two at a push. I actually need more flexibility. We know that lock-in causes you almost business generational challenges on how you move things in the future. And with AI being such a powerful new technology and way of working. I don't want to do that again. So we're seeing customers really open their approach. They're happy to try different things. They don't want to fix with one hyperscaler, one provider, one service, but have the ability to move that where their business develops and where the technology develops. One provider might be amazing at developing code for their applications, but another might be better at writing prose. Now, you don't want to throw everything in one. You want to make sure that you're putting tasks where they make most sense. And that's from, say, a macro level. As you start to look at it and break it down into the technology, we're seeing people want to build their workloads much closer to their end users as well. We started to see that in cloud over the last few years, but now agentic, much closer to where the action is happening, makes more sense. If you're trying to coordinate a multi-user, multi-system process that is trying to understand things and make real-time decisions, the closer you are to that decision point, the quicker, the better that decision is ultimately going to make. So hopefully that goes to, it's a broad overview, but hopefully that's starting to narrow down why this is a different way of working.
Now, if you look at these modern data intensive workloads, they are clearly pushing boundaries. Are we seeing new strain, new stress on the traditional hyperscale model? And if yes, what is driving it? Is it latency, regulatory pressure, scarcity, or the need to move closer to users?
Most definitely, because the cost is a pressure. The hyperscale providers have amazing technology, but the costs are substantial. If you want to make a very accurate model, you need a huge amount of data. And so trying to move that around, especially as you mentioned around scarcity of certain compute or GPU nodes, that might mean you're moving it from hyperscaler A to B or from region A to region B. And that is expensive. The cost of moving these vast data sets to where they need to be to get the most value out of them is a challenge. And making sure that where you're moving to them is sustainable for the longer term, because if you've moved it to region B, you don't really want to do a move to region C and then D and then E and so on. So just from a cost point of view, it can be a challenge. And then you do have latency. If you're trying to move these things around the world, it takes time. It doesn't matter how big the pipes get, it still takes a period of time to actually get it where it needs to be.
And when that strain builds, who feels it the most and who feels it first? The users or the hyperscalers? And how is it affecting performance, cost, and overall reliability on both sides?
So I think it's a multiple set of circumstances that have come together. So yes, it creates an impact on those end users because the ability to retrain that model or give it new data or new access to data takes time, because if you've got new sources, they have to be integrated, they have to be baked into whatever that model happens to be. The other side of that is these models are so incredible, and I'm not trying to be hyperbolic, but they essentially contain all of human knowledge to this point. And that's brilliant at a conceptual level. But if you're trying to build something that can tell you what sneakers are in season this month, and will work with what pair of trousers, do you also need it to be able to calculate the curvature of space-time near the event horizon of a black hole? Now, the chances are probably not. These are quite distinct sets. But because the model contains all of that information, it's had to be processed and churned through and manipulated and whatever else goes to it. So the models and the tokens for those models cost accordingly. Now, if you just want to be able to look at your specific data set and make decisions or interact with users based on that, that can and should be a much more affordable proposition. You couple that with moving it much closer to the users, then you fix that performance challenge, because it does take time to get from California to Scotland, where I am right now. And I'm not going to have as great an experience as someone on the West Coast with whatever chat thing they're interacting with, as I would do if it was here in, say, Edinburgh, which is 20, 30 miles away.
Just recently, we saw a major AWS outage that disrupted businesses across industries across the globe. Are these outages just unavoidable part of the cloud equation, or can enterprises design around them to maintain resiliency and business continuity?
So it's a really challenging problem. The reality is everything fails. I could be writing here with a pen and the nib could snap off. It happens. But I have another pen, or there's a pencil on the other side of my desk. I've got options. I can still write and I can continue to do what I need to do. Now that's true of technology, and it's true of cloud and any industry. What we have to do collectively is plan for that, is to make sure that we're in a position that workloads can move and are naturally tolerant of failure. So to go to your first part of the question around what is the cost of that, I wouldn't be surprised if we see some very large economic impacts released in the not too distant future, once the dust has settled, once people have had a chance to analyze it. There are the immediate impacts. I wasn't able to sell this person this thing, and that's something that you can't recover. And we're lucky it's now and not Black Friday. The other side of that is the brand and reputational damage. And that is much harder to quantify, and it is much harder to fix. And it goes on for an awfully long period of time. So there will be boards up and down the country, because it hit here in the UK and no doubt the world, who are concerned about making sure that this doesn't happen again. And we have this, it's an interesting problem in that, because this technology is so almost magical that, I switch my computer on and I'm able to join a call instantly. 10, 15 years ago, no, that wasn't it. You were dialing bridges and you were hoping that you'd remember to type it in quickly enough and all of that sort of stuff. So it has become second nature that the stuff just works. We want to keep that experience and that relationship that users and customers have with their technology. But to do that, we've got to plan for these problems. And that ultimately comes through abstraction. A more technical term might be disintermediation, but we need to break the links where your stack is all in one place, all in one provider, all with one piece of technology or sets of technology, and actually allow it to be more heterogeneous across the entire span of technology. So you might have something running on a half dozen hyperscalers, and you might not be bothered as to where they are, who they are, what they're doing, because you know that you've designed it such a way that it is as secure as it needs to be for your use case. It meets those regulatory demands, but it's also as performant, and it's able to adapt to an outage of this database or a cut deep sea fiber, whatever it happens to be. And if your users don't ever notice the problem, then you never had a problem. Now the one caution almost I would say is, because we can get to that place in the way that we design, it's then very easy to forget you have to design that in. And that does cost money. You have to want to spend the money on making your solutions and services resilient. And that's really hard when, well, it's never broken before. So why would I need to do this? That's always a challenge we've got to keep front of mind as people start to look at how they protect themselves for the future.
That ties into another big question, cloud lock-in. Many companies still sign long-term commitments for cost savings, but that can limit flexibility. That also locks them into that specific cloud provider. In your view, do these long-term contracts still make sense, or is it time to rethink that approach?
So it's all about the balance of trade-offs, ultimately. So you're absolutely right. You can go to one provider and say, yep, I'm absolutely happy to give you my business for the next 5 years, but I expect a cracking discount as a consequence of that. If you do that, you then have to accept that there is a risk associated with it. And several industry analyst providers are talking now about cloud concentration risk as a real clear and present danger to modern business. So what you can do is you can decide that I really like this service from provider A, and I'm actually happy to make a 5-year, 10-year, 15-year bet that this is awesome and it's going to serve me as a business. But if you do that, one of the things I'm starting to see people look at is exit planning. So actually putting in a line item in their budget that says, if everything goes wrong and we decide we don't want to do this anymore, how do we get out of it? And actually having that as a emergency reserve somewhere in a finance's deep, dark cupboard where they can go, we need to pivot. And actually that's not the end of the world. We can make those changes. In the same way that, I suppose at home, I would have some money put aside to buy a new dishwasher rather than having all my dishwashers be one particular brand. I will be quite happy to just buy the next available one if I need it, or then putting in a long-term service commitment with that dishwasher provider. I have rather tortured this metaphor at this point, but hopefully that makes sense.
It feels like we are moving into what you have called cloud economics 2.0. What does that next phase of cloud look like, especially as FinOps evolves into more value-driven practices?
It's a tough one. I just as a slight aside, in my last role, I was once asked to produce my budget plan 5 years in the future while I was running cloud for a major company, and I was sat there thinking, the things I want to buy probably haven't been invented yet. So yeah, it's a very tricky one. I think having a 12, 24 month horizon is a good starting point. I also think there's a big shift away from, not away from, but to complement FinOps. So FinOps has been a huge part of how we've addressed cloud in the last 10 years or so. And that goes some way to answering the challenge in the first one about overspend and making sure behaviors are reflecting what you as a business want. But I think that's going to move to, more seriously move to things like value ops. So value engineering, where you're looking at your business processes, how they map to your technology, and then measuring them accordingly. So this would be the idea of being able to say the cost of acquiring this customer might be $10. Actually taking their money from the point they hit my website to the point I get the cash is $5, and then delivery is another $5, and so on. And so you get a full chained view of where your inputs and outputs are in that value chain. And that then allows you to start going, well, yeah, it makes sense to invest in AI to help my customer experience, because I can change the average customer retention cost from $10 to $8. $2 saving. I have 2 million customers. That's a $4 million back. So I can spend $2 million to implement that improvement. That's where I see things starting to move. And it also helps buyers and the industry work on the technologies that aren't just cool, but actually have real economic value for them as a customer. The slight challenge will be, 5 years ago, we knew that AI was cool. We didn't really know what you could do with it. And it's taken this time to work out, actually, it can help me with solving this problem or this problem. I think there needs to be it looks to me like there's going to be that reset to value ops, but that does present a challenge around the investment in the new or the esoteric thing that might become the next AI.
Let's just build on top of that. How can AI itself help organizations gain true cost intelligence? Are we starting to see a new discipline forming around the intersection of AI and FinOps?
I think so. I think we're going to see, yes, absolutely the rise of agentic AI into areas that we have only imagined at this point. But where it starts to get really interesting is a combination of A/B testing, let alone anything else. So putting in yet an MCP server or an AI gateway that allows you to break down some of these traditional processes that you would have into more context aware. So instead of having a first line technician look at, oh, my server's fallen over, you're able to get the machine to look at all the possible causes for it, narrow it down, and get to a point where, oh, I can just very quickly hand that off to a tier 2, tier 3 engineer. But using the same type of, and with the same approach, you can start to look at your financial modeling. You can start to better predict that, I'm definitely going to have a surge in uptick on the payroll server because it is month end and I need to generate a bunch of paychecks and email them out. Now, we know that we can program that with things like cron jobs to expand it in and out. But if you have more dynamic processes that could be, weather related. Let's say you're a big supermarket and you want to make sure that you're ordering more ice creams because it's going to be sunny in this county in the UK, but it's going to be horrible everywhere else. You could start to use agentic to go, it's really warm there, I'm going to send thousands of ice creams there and redirect the ones that were going to go to all my other stores in the country. I haven't increased my costs, or I'm really bought any more ice creams. I've just diverted them to the right place. So I've become more efficient. And that's where it has a huge impact on that wider space of FinOps or value ops going forward.
If a CIO stopped you in an elevator and asked, how do I build cost intelligence into my cloud strategy? What metrics or guardrails would you tell them to prioritize?
I would start with coming up with 3 values or principles that you want to inject into this. There's no point deploying a technology because everyone else is saying you should do this. What you should be doing is starting from the point of, I need to save money, I need to grow my business, or I need to reduce risk. What are the things that are important for me in the next 12, 24 months? Obviously, every CEO wants to do all of those things, but we all know that you can't do everything all of the time. You've got to focus or you go everywhere. So work out what you want out of something, and then also work out a way that you cannot be locked into any one service provider. Make sure that what you're building and what you're asking of your teams and partners is a service or a solution that is flexible, that can move with your business. And those are the 2 or 3 critical things to start with. We absolutely can dive into making sure your data's inexpensive, you've got it at the right tiered storage level, you've compressed it, all of those detail pieces. But if you don't start from the beginning of making sure these guardrails address things that matter to you as a business, then you're not going to be as successful as you'd hoped.
What about globally distributed apps, especially across regions like EMEA? What is the practical playbook you're seeing which has been successful? A centralized core with regional edges, data resiliency by default, and when does it really make sense to shift workload across providers?
Yeah, so it really depends, which I know is a very wishy-washy answer, but I'm certainly seeing customers concerned about the costs of cloud from big centralized providers, and in particular from centralized AI providers. They're also the ability to actually roll your own versions of models or experiment with different models is becoming more and more relevant. So there is a core and distributed edge approach here, remarkably similar to network design, which makes quite a lot of sense when you think about it. We want to bring everything into the center to train a large model or whatever you're trying to achieve, but you want to send the product of that model out as close and as distributed as you possibly can to where your service operates so that it is more performant and more efficient for you. It also means that you can get the economies of scale you need. So you get a ginormous cluster of GPUs for 8 hours to process your model once a week or a month or whatever makes sense for you. You're not sat there with all of these running all of the time, nor are you sat there burning tokens because you've imported 50,000 files and each one of them has to be burned through in order to let you generate an update. So it's starting to move in those core where it makes sense, edge where you want to impact the user.
Finally, if you had to leave our viewers with one piece of advice, what's the single most important principle for designing a modern cloud strategy that is cost-aware, agile, and future-proof?
One of the things I keep coming back to is that ability for customers to control their own destiny. And it's almost plan to leave before you plan to start as a something of a soundbite to how you start implementing new AI projects or cloud projects, because some things are going to work and some aren't. And having put all your eggs in one basket and being reliant on them, no matter how good they are as a provider, does put too much risk, in my mind and what I can see, out with your control. And that's not a comfortable place for lots of organizations to be.
John, thank you so much for joining me and sharing these insights. It's quite clear that modern cloud strategy isn't about lift and shift or cost saving anymore. It's about placement, flexibility, and intelligent design for AI-driven workload. Thanks for joining me, and I look forward to chat with you again. And for those watching, if you're facing similar challenges, make sure to check out Akamai and its solutions, and don't forget to subscribe to TFIR, like this video, and share it with your team. Thanks for watching.